Welcome to the last section of this advanced predictive analytics course. In this section, we will take everything that we learned in the last section and we will put it into practice. So we are going to do some predictive analytics with TensorFlow and deep neural networks. Okay, let's see what we are going to learn in this section. We will actually do a lot of things. This is a very practical section. So let's see what we are going to do. In the first video, we will perform what is now considered as the hello world of deep learning. This is an example that is maybe a little bit overused. However, I think it will give you a good introductory example so you can see how a program that uses TensorFlow looks like. Then in the second video of this section, we will perform a regression with a deep learning model, and in this case we will be predicting again the diamond prices. And finally, in the last video, we will perform classification with a deep learning model, and in that case again we will use the credit card default dataset, and after that you can compare the performance of these advanced models with the performance of the models that we used in previous sections. Okay, this is the first video of this section, predictions with TensorFlow, an introductory example. In this video, first we will talk a little bit about the MNIST dataset, and then we will go to the Jupyter notebook to actually build a deep learning model to classify handwritten digits. Now, in case you don't know about this MNIST dataset, this, MNIST stands for Mixed National Institute of Standards and Technology, and these people from this institution produced this handwritten digits dataset. This is one of the most researched datasets in machine learning, and when using this dataset, the goal is to classify handwritten digits. This dataset contains 60,000 training images and 10,000 testing images, and they are formatted as 28 by 28 pixel monochrome images, and this is how these images look like. So as you can see, for every handwritten digit you have the corresponding true label, so we can use this dataset to build classification models. So we can use the image to classify the image into one of the 10 digits from 0 to 9. So now we are going to do this with TensorFlow and deep learning. So let's go to the Jupyter notebook. Okay, so here we are in the Jupyter notebook. These are the libraries that we will use. We will use TensorFlow, NumPy, and Matplotlib. And from TensorFlow contrib layers, we will import the this function, fully connected. This is the function that we will use to build the layers of our network. Okay, so let's run this cell. Now, remember that in the last section we talked about all the elements that we need to consider when we are building a multi-layer perceptron model. And in this case, these are the elements that we will use in this example. For the architecture, you know, the input layer, the number of neurons in the input layer is given because we have 28 by 28, so each pixel will be a feature in this case. So we have 728 pixels. Yeah, pixels by image, and each pixel will be a feature. So we have 728 features. Now, since this is a 10 category classification problem, we will have 10 elements in the output layer. And these are the hidden layers that we will use. This is our choice. So we are going to use 3 hidden layers, and this is the number of neurons that we will use in each layer: 350, 200, and 100 in the last layer. Okay. Now, for the activation function, we will choose the relu activation function, and this is how this activation function looks like. So this is a relatively simple function. If the input is negative, the function outputs 0, and if the input is positive, the function just outputs the same value as the input. So mathematically, the relu function looks like this: is the maximum between 0 and the input. And this is how this activation function looks like. So this is the activation function that we will use in every neuron of our hidden layers. Okay. Now, continuing with the other elements of our model, the optimization algorithm that we will use is the gradient descent, and we will use a learning rate of 0.01. Now for the loss function, we will use the cross entropy function. Now you can learn more about this function, but as with other loss functions that we use in this course, this function measures the distance between the actual values and the predictions that the model makes. Okay, so now this function has been shown in research to work really well with deep learning models. That's why we are going to use it. For the weight initialization strategy, we will use the Xavier initializer, and this is a method that actually comes with this as default with this function that we will use, so we don't need to worry about that. Now we are not going to use any regularization in this example, and this is the training strategy that we will use. We will present the dataset 20 times to the network, and in every iteration we will use a batch size of 80. So we are going to present the data to the network 80 points at a time. Okay, and we are going to present the whole dataset 20 times. So that's why we are going to use 20 epochs. Okay. Now, one of the reasons for using this dataset is that you can get it very easily from TensorFlow. So in this cell, we are basically importing this dataset, and we are saving this into a folder called data. Now let's actually build the network. So this is the architecture that we will use. As we said before, these objects are the placeholders for inputs and labels. So these are the objects that we will use to pass the data when we are training the network. Okay, so we have a placeholder for the features, and this is basically the input layer, and we have a placeholder for the target value. So this object will contain the actual true labels of the digits. Okay, now in this cell we build the actual deep neural network. So for the first hidden layer, we will use the fully connected function. So the input for this hidden layer will be x, so will be the data that will come from the placeholder, and this is the number of neurons that we have in this hidden layer. Remember, we have 350. Now this hidden layer 1 will become the input for the second hidden layer, and this is the number of neurons that we will use in this second hidden layer. Likewise, this hidden layer 2 will become the input for the third hidden layer, and we will use this number of neurons in this layer. And finally, the output layer, we will call the output layer logits, and this will be a fully connected layer that will use as input the hidden layer 3. This is the number of outputs. We know it's 10 because we have 10 categories in our classification problem, and we know that in the output layer we don't use any activation function. Okay, so this is the cell where we build the actual deep neural network. This is the loss function. So we are going to use the cross entropy, and TensorFlow provides us with many functions that we can use. For example, in this case, we will use this function sparse softmax cross entropy with logits, because what we got from the network are the logits. So in this function, we pass the actual labels. So these are the true labels, and these are the logits, the results or the output of our network. Now, using this cross entropy, we can calculate the loss as the mean of this vector that we will get here. Okay, so this is our loss function, the mean of the cross entropy. Now let's define the optimizer and training operation. This is the learning rate we will use. We will use the gradient descent optimizer with this learning rate, and as we did in the example of the last section, the goal of the optimizer is to minimize the loss. And the optimizer will minimize the loss by adjusting the weights, the different weights that we have in all the layers of our network. Okay, so this is the training operation, each time we run the training operation, the optimizer will change the values of these weights a little bit, so in a way that it minimizes the loss, so the predictions and the actual values are as close as possible. Okay, now these are a couple of nodes for measuring, for evaluating the accuracy of the classification. And here we set the training strategy. We will use 20 epochs with a batch size of 80. Okay. Now, in all of these cells, what we have done so far is to build the computational graph that will be used in this program. Now, we have to actually run the computational graph. Remember, we run computational graphs inside a session, and we can use a with statement in this case. So in this case, we will use a with statement. We create a session, and we will call it ses. So here, what we are doing, let me get the lines here. Okay, so in line 3 we will initialize all the variables in our program. Now here we don't have any variables explicitly. However, the variables are inside this fully connected, are implicitly inside this fully connected function, because in this fully connected function is where we have all the hidden layers, and the hidden layers contain the weights. So these are the variables. That's why we must initialize the variables with these global variables initializers, and we must run this node. Okay, now we are going to do the training of the network. So for each epoch, we are going to run this loop for 20 times. Now, for each iteration that we have in the number of examples over the batch size, which is 80, what we will do is we are going to get the values for the features and the target. So this will be 80 data points for each iteration. Then we will run the training operation, and we will pass as x, we will pass these the feature values, and here we will pass the target values. Remember, x and y are our placeholders. Then we will evaluate the accuracy of the training in training, and then we will evaluate the accuracy in the testing dataset. And we get the testing dataset from MNIST.test.images, and so these are the features, and test.labels are the targets. Okay, then we will print what are the two accuracies, and after these two loops are completed, then we will produce here some individual predictions for the first 15 images in the testing dataset. So let's run this and let's see what we get. Okay, so in the first epoch, training accuracy is 86%, and the testing accuracy is 88, almost 89%. Okay, now let's see how it goes. So as you can see, both training accuracy and testing accuracy, this is actually the one that we care about, is going up. Okay, now as you can see, these programs take a little bit of time to run, but after 20 epochs, you know, the testing accuracy is almost 97%, and when you use this trained network to predict actual values, this is what you get. So these are the actual labels, the true labels, and these are the predicted labels that these are the predictions that the network made. So congratulations, you have built your first deep neural network model in just 12 code cells in this Jupyter notebook. You have built your first deep neural network model, and you were able to classify handwritten digits using this program with almost 97% accuracy. Okay, great. I hope this introductory example clarified a little bit how TensorFlow works, and now we will move